Welcome to This Explainer. Today, we're diving into a mind-bending story that takes a massive environmental headache and transforms it into an incredibly valuable resource for renewable energy. Think about this for a second. What if the world's most invasive weed is actually a secret energy source? For decades, the water hyacinth has been viewed purely as a destructive force. But as we comb through the scientific literature and recent field studies, a completely different narrative emerges. What if the very traits that make it a terrible pest are exactly what make it a secret, untapped bioenergy powerhouse? Here is our roadmap for today. We'll start with the water hyacinth paradox, look at nature's water purifier, and tackle the biomass bottleneck. Then, we'll get into the really good stuff, turning that biomass into biogas, the anaerobic digestion process, and how all of this creates the sustainable energy cycle.
Part 1. The water hyacinth paradox, a fast-growing aquatic nuisance. We're talking about Eichhornia crassipes, a plant notorious for causing severe environmental headaches across tropical and subtropical regions globally.
This plant is incredibly invasive. A single plant can shoot out horizontally growing stolons and create massive mats of daughter plants that literally double in size in just 8 to 18 days under the right conditions. This explosive expansion quickly chokes entire waterways, halts boat traffic, and totally disrupts local ecosystems by blocking out sunlight and depleting oxygen. By all traditional measures, it is an absolute menace.
Which brings us to Part 2, nature's water purifier, the hidden superpower of phytoremediation. Here's where the story shifts, because researchers found that this aggressive growth relies on a massive appetite for absorbing impurities.
Imagine highly polluted industrial effluent, like the discharge from textile mills or municipal sewage, loaded with toxic metals and severe odors. Now imagine clear, revitalized water with a neutralized pH and up to a 97% drop in organic waste. That is exactly what happens after the hyacinth's deep, fibrous root system goes to work. The roots act as a biological substrate where microorganisms absolutely thrive, breaking down organic matter with stunning efficiency.
It acts like a giant biological sponge, pulling incredibly dangerous heavy metals right out of municipal sewage and wastewater. The literature shows it effectively absorbs cadmium, lead, copper, and zinc. In one study focusing on textile wastewater, water hyacinth reduced chromium levels by a staggering 94.78%. It's a total powerhouse for cleaning up some of our most toxic messes.
But that leads us to Part 3, the biomass bottleneck. What happens when the purifier becomes the problem? While the water gets clean, facilities face a massive new issue. What do you do when the purifier itself turns into a mountain of waste?
Get this, 154. That is the staggering potential metric tons of water hyacinth biomass that can be produced per hectare every single year. Because the plant grows so fast while it cleans the water, treatment facilities suddenly find themselves swimming in tons of wet, dense plant matter. And you absolutely cannot just leave it there. If we don't physically harvest this biomass, the older plants simply die, sink, and decompose. That rot consumes the dissolved oxygen in the water, and worse, it releases all those heavy metals and absorbed toxins directly back into the environment. We have to harvest it, but what on earth do we do with 154 tons of wet weed?
Enter Part 4, turning biomass into biogas, the energy pivot. This is where we uncover a massive opportunity to pivot from waste management directly into renewable energy generation.
To unlock this energy, we rely on anaerobic digestion. Think of an anaerobic digester as a giant, sealed, mechanical stomach. It's an oxygen-free environment where specific types of bacteria break down the soft, organic matter of the harvested hyacinth. But just like a real stomach, it needs the exact right diet and gut flora to function optimally and pump out usable power.
So let's look at Part 5. The anaerobic digestion process, step-by-step renewable fuel generation. How exactly do we feed this mechanical stomach?
The journey starts by harvesting all that massive biomass from the treatment ponds. Then, and this is a critical step, we mix the plant material with animal dung, like cattle manure. Why? Because the dung acts as a seeding material. It introduces the precise natural bacteria required to kickstart fermentation. Then, this mixture gets sealed inside the digester to ferment. Finally, we collect the rising gas, which is our clean, renewable methane biogas. The science behind why this specific plant works so well for biogas is actually fascinating. Microbes in a digester need a specific diet to thrive. measured by the carbon-to-nitrogen ratio. They need carbon for energy and nitrogen to build cell structures. The ideal range is broad, from 12 to 1 up to 72 to 1. But Water Hyacinth naturally sits right at the biological sweet spot of 20 to 30 to 1. Combined with its high water content and soft organic tissues, it is a virtually perfect bioenergy feedstock.
When the digestion process finishes up, the resulting biogas is highly combustible, averaging a fantastic 60% methane content. The rest is mostly carbon dioxide and a few other gases. This isn't just some weak byproduct. This is a potent, high-quality gas, ready to fuel industrial boilers, heat homes, and straight-up replace traditional fossil fuels. Which brings us to part 6, a sustainable energy cycle, closing the loop on waste and power. We've successfully converted a water-choking weed into clean energy, creating a perfectly sustainable loop.
It is a zero-waste system with some truly amazing byproducts. First, we get that clean biogas fuel. Second, when the digestion is done, the leftover slurry, the sludge, doesn't just get thrown away. It is incredibly rich in nitrogen, phosphorus, and potassium, making it a premium agricultural fertilizer. And third, researchers even found that when you use clean, safe portions of the harvested hyacinth as duck feed, it surprisingly increased eggshell thickness by 9.43%. Every single part of the plant gets utilized.
Ultimately, it's a total paradigm shift. As the literature perfectly summarizes, producing high-quality vegetable protein, vitamins, fertilizers, and energy in the form of biogas completely strips away the nuisance value of this weed. We've unlocked a massive potential provider of clean water, agricultural fertilizer, and desperately needed renewable energy.
So, I'll leave you with this final thought to ponder as we wrap up this explainer. If a notorious weed that has plagued waterways for decades can actually be harnessed to clean our toxic water and power our homes with biogas, what other overlooked natural resources or so-called pests are out there right now just waiting to be tapped? Thank you for exploring the water hyacinth paradox with me today. Keep questioning the world around you, and I'll see you in the next explainer.